In this video, we're going to look at complementary events. Before we do that, let's familiarize ourselves with some key words. So probability is how likely an event is going to happen. It's the mathematical description of chance. Event is a single result of an experiment. I toss a coin, I get a head. Outcome is the result of an experiment, heads or tails. Complement of an event are all the outcomes which are not that event. So for example, the complement of tails, which is written with a little bar over the top, would be heads. The probability of getting heads is half. And the probability of getting a tail is also half. And if you sum the event and the complement of that event, you will get 1. Sample space is the list of all outcomes of an experiment. If you play a football match, you can win, lose, or draw. That is the sample space of a football match. Okay, the probability of an event occurring, E, is written like this. And the probability that event does not occur is written with the bar over the top, and that is the complement of that event. Okay, so let's have a go at a quick starter. This should be familiar to you, and I would like you to use the appropriate notation discussed in the previous slides. Pause the video and see if you can do this question. Okay, so hopefully you've done that now. So let's go over this question very quickly. The probability of getting an even number, we write that probability even. Okay, well, 2 is even, 4 is even, 6 is even, and 8 is even. So that is going to be 4 over the total number, which is 8, which is equal to half. Okay, the probability of not an even number, that is written probability even with a bar over the top. Well, the probability of not getting an even number, 1 isn't even, 3 isn't even, 5 isn't even, and 7 isn't even. So that is 4 over 8, which is equal to half. Okay, the probability less than 5. So we are going to define our variable as x. Less than 5. Less than 5 is going to be 1, 2, 3, and 4. Which is 4 over 8, which is half. We don't include 5 because it's less than. So the probability of not less than 5 is written like this. And that is just simply going to be half again. Okay, so I'm going to give you the formula for probability. And I want you to copy this down. Formula for probability is as follows. Okay, so the probability of E is equal to number of outcomes matching E all over number of outcomes in sample space. So let's define E as odd number. And let's roll a die, and the sample space is going to be 1, 2, 3, 4, 5, and 6. Okay, the sample space is what we call a set. And a set has an important significance in discrete maths. And we define a set by these curly brackets there. An event is a subset of a set. So odd is going to be 1, 3, and 5. That is going to be 3, and the total number is going to be 6, which is half. What about the probability of not getting an odd number? Okay, hopefully you've paused the video and done that. The probability of not getting an odd number is going to be 2, 5, and 6, which is 3 over 6, which is half. And I hope you can notice that the probability of event E and the probability of E not happening is 1. And that is an axiom in probability. That's something which is always true, like a law. And we're just going to be really explicit about that now. And I would like you to copy this down into your books. It's really important that you define probability like this, and you're not just writing fractions or decimals. Okay, so hopefully you've written that down. Let's have a look at an example. Okay, a fair coin is tossed. List the sample space. Calculate the probability of the following events. Pause the video and see if you can do this. Okay, so hopefully you've done that now. Curly brackets for a sample space. List the sample space. Well, we're going to get head and we're going to get tail. Okay, so calculate the probability of getting a tail. Well, there's 1 tail and there's 2 in the sample space. Probability of getting a head, there's 1 head and there's 2 in the sample space. So the probability of not getting a tail, well, I hope you can see that the probability of not getting a tail is 1 minus the probability of getting a tail. Or we could just simply count the number of terms which are not tails, which is head. There's 1 of those and it's out of 2. The same logic is for not getting heads. It's a half. Okay, let's have a look at another question. So a fair die is thrown. So first of all, die is the singular of dice. So dice is plural, die is singular. Fair means that all the outcomes in the sample space are equally likely. In other words, 1, 2, 3, 4, 5, and 6 all have an equal chance of occurring. Okay, pause the video and see if you can answer these questions. So hopefully you've done that now. Curly brackets for a set. We've got 1, 2, 3, 4, 5, and 6. Okay, the probability of getting a 5, well, there's 1 5, and the total possible number of terms in our sample space is 6. The probability of not getting a 5, well, we could subtract from 0, or we could count the number of terms which are not 6. Well, I'm going to subtract from 0 then. And that simply gives 5 over 6. The probability of even, well, I hope you can see that that's 3 over 6, which is a half. Probability not even is going to be 1 minus the probability of even, which is just going to be half. Okay, the probability of less than or equal to 3. Okay, so 1 is less than or equal to 3, 2 is less than or equal to 3, and 3 is less than or equal to 3. So we have 3 over 6, which is half. Okay, not not less than or equal to 3. I'm hoping you can see that that is half. And then finally, not greater than or equal to 1, but less than or equal to 4. So I'm just going to do this in, let's do it in, so this inequality here is that, and the line at the bottom means including. So not in between that inequality is 2 over 6, which is a third. Okay, so hopefully you have a good understanding of complementary events, and you can use the correct terminology when describing probabilities, and you can use the complementary law in probability to calculate the complement of events. Okay, marvellous, and good luck with your probability work.